Alright, so today we're going to look at one of the most confusing or interesting problems that we're ever going to see in the history of mathematics, or to say in the history of your mathematical area. So we're going to talk about something called the ambiguous case. The ambiguous case. So before we start, let's define ambiguous. So ambiguous actually means open to more than one discussion, open to more than one interpretations. There's a double meaning to it. So how can this possibly apply to mathematics? I mean, usually math compared to biology or English, it has a definite answer. Well, I just wanted to show you something. Let's say if I had this triangle of A, B, oh, B, and C. So I haven't drawn in side A yet, but I just want to show you something. So how can we actually create a triangle? So we can draw any A right now. How can we create a triangle? Well, we can create an angle like this, right? We can create an angle like this. So this is a 90-degree angle, right? We can create this, or we can draw it inwards or outwards, right? However, first let's see how would we go ahead and find this 90 degrees. So we can use Pythagoras theorem, we can use SOHCAHTOA, or we can use sine law, right? So this it will become a 90 degrees angle. However, what if we have so let's say what if side A is longer than B? So we can only create an angle like this, right? It goes so mega far. It goes so far out here, right? This is how you create this triangle if you have an angle that's larger than B. So I want you to notice you can only create one solution if A is greater than B. So if A is equal to B, there's only one solution. So if A equals to B, we can make one triangle. If A is bigger than B, we can also only create one triangle. So we're only talking about if it's bigger than A, if it's bigger than B and we have a definite value. We're not talking about we're talking about, let's say B was 5. We're not talking about 6, 7, 8. We're only talking about what if I have 6, then there's only one way to create this triangle, right? So if A is bigger than B, there's one triangle. However, the ambiguous case comes when we have what if I have an A that's smaller than B? So let's say I have 4. So I can draw it inward like this, 4. But however, I could also curl it outward like this, 4. See, this is a perfect what was top? So this is a triangle that we just created. That look, wait a minute. How do we know which one to create? Right? We create this isosceles triangle, but we're like, hey, wait a minute. If I use this SOHCAHTOA or if I use sine law, how do I know which one I'm solving for? So now, when you have this is the ambiguous case. When you have A less than B, you can actually create two triangles. So this actually leads to many new solutions to questions that ask us to draw. So let's go ahead and try out today. So there's a question specifically to solutions. So let's go ahead and try out these questions. First, let's go ahead and do this example one. I'm going to leave this diagram that I drew up there. So we're going to draw all the diagrams ourselves today, simply because I don't feel like giving you the diagram anymore. I can't just be feeding this to you on your test. So ABC. If I had this triangle of 44.3, and A is 11.5, and B is 7.7, round the side length to the nearest of a meter. Okay, so I guess they're asking us to solve the triangle. So first, let's go ahead and get the other side. Let's get side C. So this is side C. How do we get side C? Well, we can use sine law, right? So sine 44.3 over 11.5 is equal to 7.7, and we're doing sine B. Right? So we're trying to find sine B. So let's go ahead and solve that with our calculator. So 7.7 multiplied by sine of 44.3 degrees. It's going to go ahead and get us 5.37. And then we're going to divide that by 11.5. So now we're going to have 0.46. We do the inverse sine of that. We're going to get 27.88 for our angle B. 27.88. 27.88. So B. Let's go ahead and find C. So C, we can use the inner angle. So 180 minus 27.88. I'm going to round that to 27.9 minus 44.3. That's going to give us 107.8. So since we are drawing the diagrams ourselves, it's very likely that our angle is not going to be that good. So don't use the diagram too much when you draw your own angles. So just try to keep to the math and trust the process. So C was what? 114? 107, yeah, 107.8. And now we can just simply find side C by using sine law again. So sine of 107.8, sine of, okay, so I'll just write this continuous. Sine of 107.8 is equal to, over what? Over C. So let's go ahead and find that. Sine of 107.8 degrees multiplied by 11.5 divided by sine point 44.3 degrees. Sine of 44.3. Okay, so C is equal to 15.677. Rounds up to the nearest tenth. So C is equal to 15.67. 15.7 meters. And there we have solved the triangle. Now let's go and talk about the actual ambiguous case. This is very ambiguous, guys. Keep in mind, very, very ambiguous. ABC. I'm going to draw this. This is always, for me, this is how I always draw it. So let's say this is 29.3. And then this side, oh, this is B. This is 20.05. And this is 12.8. And we created our first triangle, so I'm going to draw that here. I'm not going to label it because we already know. However, we can also draw our second triangle. Right? So now let's go ahead and solve it and see what's different. So first, for the first one, let's go ahead and find out the other angles. So we're going to do sine of 29.3 over 12.8. It's going to equal to 20.5, and then that's sine B. And then sine B is going to go ahead and equal to 20.5 times sine 29.3 degrees divided by 12.8 inverse 51.6. So right, and then let's do C. Since we just do 180, we'll get 99.1. Right? No problem. And now we just need to find side C. We're going to use sine law again. So the first one we use sine 29.3 to, let's go ahead and find that. Sine 99.1 degrees times 12.8 divided by sine of 29.3. Go ahead and get 25.82. Alright, let's go ahead and find this one. So now, what doesn't change? What doesn't change? What is one thing that doesn't change? Okay, so sorry. So what is one thing that does change? Look at it and be like, wait a minute. I think B changes. Exactly. So if we look earlier, this doesn't, this 51.6 doesn't actually correspond to this. It actually corresponds to that. So now this is why it's ambiguous. We do not know, and you do not. You if you don't look it carefully, there's going to be no difference. So now, how do we find the other value that gives the exact same sign value? Hey guys, that was the sign property we learned earlier. So now 180 minus 51.6. What is that? That is going to go ahead and give us 128.4. So side B, 128.4. Right? And now we need to find C again. So since we changed, we're going to do 180 minus 128.4 minus 29.3. So C is going to go ahead and change to 22.3. Don't forget the degrees. And then now we're going to find C. So we're going to go ahead and do sine of 29.3 over 12.8 is equal to sine of 22.3 over C. Let's go ahead and calculate that. Sine of 22.3 degrees times 12.8 divided by sine 29.3 degrees. It's going to go ahead and give us 9.9 meters. So we have finally solved the entire ambiguous case. So now we have two triangles that we solved. Remember to always check, hey, which angle is the ambiguous one, what changes, and see how these correspond to each other. Now let's go ahead and do one of the most interesting, I would say, questions out of the entire textbook and the trig unit. Quarter of a circle. 15 centimeter line segment, PC. So I'm going to draw that, PC. So this is PC. Is drawn to an angle 47 to a horizontal degrees. So remember what I meant. So a horizontal line is something like this. So 47 degrees is always going to be the angle of elevation or the angle of deflation. So it would have been either like this or this. So I'm going to draw it like this because I feel like that's better. So this is 15 centimeters. A circle with the center C. So I'm not going to label anything yet. So a circle with the center C. So let's say we have a circle and a radius of 12 centimeters intersects PT at R and S. So let's think about it. How can this thing, so the PT, right? Okay, so this is PC. So I assume this is point P and that's point C. So a circle with a center PT at R and S. So if this is point T, so this is T. So they intersect at 2 points, R and S. So let's think for a minute. How can this radius intersect at 2 points? Right? That sounds a little weird. So let me redraw that because I need to draw it larger. How can they intersect at 2 points? Right? So the only possibility is we have the ambiguous case. So it's actually something like this. So it intersects here and intersects here. And this is R and S. So calculate the length of the chord R and S. So essentially this is going to be what we're trying to find. Now that we understood the diagram, let's go ahead and solve it. So remember that we actually have an isosceles triangle here, because this is the ambiguous case. And the radius is always the same at all points of the circle. Wow, I can draw a straight line now, huh? Okay, so that is that. So let's go ahead and look how would we really find this. So if this is 12 and this is 15 and this is the angle that we already have, 47. So let's go ahead and find, so let's find this first. So let's find this angle first. So we're gonna do sine of 47 degrees over 12 is going to give us sine of this angle right here, sine theta, over 15. Let's go ahead and find that. 15 times sine 47 degrees divided by 12. And inverse sine of that, it's going to give us 66.1 degrees. So theta is 66.1 degrees. 66.1 degrees. So we have that here. And now with what we see right now, which angle did we find? Right? Which angle did we find? Well, we found this one. We actually found that one. Right? However, remember, this is an isosceles triangle. So if this is 66.1, this also had to be 66.1. So now we can actually find the upper angle. So 180 minus 66.1 minus 66.1 again. So that's going to give us 47.8. So this angle right here, that's 47.8. Right? And now we can find x. Right? Can we not? So how do we find x? So we look at it around and be like, is there a cosine sine law that we can use? And be like, yeah, sure. Let's just use cosine law. So you can definitely use sine law here, but it depends on what you want. So I'm gonna go ahead and use sine law. Sine of 47.8. Wow, 47.8 over x is equal to sine of 66.1 over 12. Let's go ahead and find that. So sine 47.8 degrees multiplied by 12 divided by sine of 66.1 degrees. So my x is going to be 9.72. What do we need to round? Nearest 10th. So 9.7 meters. Or centimeters, right? Centimeters? Yeah, centimeters. And finally, since we set x equals to r and s, we just solved it. We have solved it. So the length of the chord RS is 9.7 centimeters. No problem. Finally, I'm going to show you the only question that I gave you a diagram today because I'm such a nice person. The light of a rotating offshore beacon can illuminate effectively up to a distance of 250 meters. A point on the shore is 500 meters from the beacon. From this point, the sight line to the beacon makes an angle of 20 degrees. So that's basically the angle of elevation. What length of the short line to the nearest meter is effectively illuminated by the beacon? So let's think. What are we trying to find here? What is going on? So we have a diagram, but we don't know what's going on. So first, let's look at this beacon. This beacon can light up 250 here, 250 here, but since we only have two sides, we can only draw that. But if we look at it around, like if we look at it above, this is the beacon, and then it can illuminate a distance of 250. I'm sorry, that's not a good that's not a good circle, but you know what I mean. So in a circle, in a triangle, it's gonna look something like this. So we have the beacon, 250, 250. That doesn't look 250. So we want to see. This is basically the same thing like the last question. So we want to find this length. Let's say this is x and y. So actually, you know what? This is gonna be AB. So we want to see how many in a total distance is covered by the beacon. So this seems weird to ask how many of a distance, because if you're asking distance, it can only be like a line like this. But realistically, we're not going to worry too much because we're dealing with the 2D problem, and that's all that matters. We're gonna deal with the 2D problem, and we're gonna stay and deal with the 2D problem. So let's go ahead and see what can we do. We're gonna approach it pretty much the same way as we did to the last question. First, find this part. So 50, 500. So let's do some laws. I'm gonna go ahead and do. Okay, so use the 500. Okay, let's use the sine law. Right? Let's find x. Well, sine x. Sorry. Sine of a, I guess. So 500 times sine of 20 degrees divided by 250. Inverse sine that. It's going to give you a acute angle. So 43.16. Let's think. Which angle is that? This angle. 43.16. Now we're going to use the same strategy. 43.16. So 180 minus times 2. 180 minus 43.16 minus 43.16. 93.62. 93.62. 68, sorry. Let's go ahead and use the sine law again. 43.61 over what? X. So x is going to go ahead and get us sine of 92.68 degree. Let's multiply that by 250. And we're going to divide it by sine of 43.61 degrees. Finally, it's going to give us 362. What do we need to round to the nearest meter? Okay. Finally, we have found the answer. 362. 362.055, and that is the entire answer that we're going to do. Okay? So that is pretty much the entire lesson. However, I do wanted to go through a couple practice problems with you guys, simply because, hey, you know what? Practice makes perfect. And I just have to confirm my answer for this. Yeah, okay. So let's go ahead and deal with the, practice questions. So this is a typical problem solving question. So let's see. Triangles are formed by the intersection of the lines y equals x, y equals 2x, y equals negative 2x, y equals negative 4. As shown for ABD and ABC. So, little hard, but that's okay. First, let's come in with some coordinates, I guess. Oh, what am I writing? So, let's try to find the point of intersection of these little things. So let's imagine that we're on the Cartesian plane. So where would possibly everything intersect? So we set this, and then we're like, hey, wait a minute. There's no way that these are going to intersect at any other point besides. Whoa. So we actually have some coordinates. A is 0, 0. Now let's find B. So where does y equals x intersects y equals negative 4? What? What? Y equals x, so x equals negative 4. We already know. So y equals negative 4. So essentially, A is 0.000. This is negative 4, negative 4. And then let's look at D. Where does 2x intersects negative 4? So 2x equals to negative 4. We're going to divide both sides by 2. So x equals negative 2. So this happens at negative 2 and negative 4, right? So let's first, we have already made this. Let's go ahead and see, let's solve it, because this is ABD. So in the middle, we have this little distance here, BD. It's going to be 2, right? Not much question. 0, 0. So, how many blocks we traveled here? We traveled 4 blocks up and 2 blocks to the right to get to this. So how do we find the distance? Should be pretty easy, guys. Okay, so to find this distance here, we're gonna do 4 squared. So we're gonna just simply do the Pythagoras theorem. So 4 squared plus 2 squared cubed. So it's gonna be 16 plus 20, so square root 20. So square root 20. Right? And then we can go ahead and find the last part by seeing this. So we traveled 4 units to the left, 4 units down. So 4 squared. So 4 squared plus 6 plus itself divided by 2. No, sorry, square root that. It's gonna be square root 32. And then the angles are pretty easy to find, so you guys can do that on your own. And we can basically do the same thing for C. So we're gonna go ahead and find the point of intersections, and then we solve it. So that is pretty much it for the questions. So the homework of this class, it is on page 308 and 309. So this is pretty much the end of our Is this the end of the trigonometry unit? Yes, so this is the end of the trigonometry unit. We're gonna get into some trigonometric functions next. And if you have any questions, please ask, and